All right, this is our first lesson, Chapter 1, on nets and drawings for visualizing geometry. And we're going to start right out with our vocabulary, talking about what a two-dimensional and a three-dimensional figure looks like on paper. Whenever we have these hidden lines here, those are three-dimensional figures, and just flat surfaces, those are two-dimensional figures. So number 3, you can see with the hidden lines there, that's also going to be a three-dimensional figure. All right, the definition of a polygon is that it's a two-dimensional figure that has 3 or more sides, and each of those sides meet at exactly 2 other sides at the endpoints. And the main idea here that I'd like you to focus on is that right here, it's always a closed figure. That's going to be very important. All the sides meet. There's no open sides, and none of the sides cross each other. Okay? So those are very, very important parts of your definition for a polygon. And there's some examples there for you as well, some specific names of polygons. So let's go ahead and use our definition of what a polygon is to go ahead and solve some problems here or answer some questions. Number 4, it says underline the correct word to complete the sentence. A polygon is formed by how many? 2 or 3 or more straight sides? Well, we said it has to have at least 3 sides. A circle then, is that a polygon? Well, it doesn't have straight sides, so it is not a polygon. Which of these, a triangle or rectangle, is a polygon with 3 sides? Well, I think you pretty much already know that one. Number 7, the sides of a polygon are they curved or straight? Well, those are straight. Number 8, 2 or 3 sides of a polygon meet at the same point. Well, only 2 of those at a time meet at the same point. Number 9 says cross out the figures that are not polygons. Well, the figures that are not polygons, just remember our definitions. There is no open sides allowed, so that is definitely not a polygon because of the open side. Here we have sides that are crossing. That's not allowed, so it can't be a polygon. And this one has straight sides. It's closed. It's a closed figure, and none of the sides cross, so that is definitely a polygon. And then let's go ahead and move on to number 12. Underline the correct words. A net is a 2 or 3-dimensional diagram. Well, a net is a 2-dimensional diagram. Excuse me here. Let's see if I can get this to work. And you can fold a net to form a 3-dimensional figure. Number 13, circle the net that you cannot fold into a cube. Well, the one that you cannot fold into a cube here, this one definitely folds into a cube, and this one's very similar. That one will also fold into the cube, but the one that does not fold into a cube is the one in the middle. Oops. Use the net of a cube at the right for exercises 14 and 15. If we folded this into a cube, it says what color will be opposite each face? Well, what's going to be opposite the red face? Well, opposite the red face would be what's right below the yellow, which is going to be the orange one right here. So that's going to be orange. Opposite the blue face here will be 2 squares over. That will be the yellow. And opposite the green right here, well, that one's going to be 2 squares over, which is going to be the purple. Okay, if you're not understanding these, just take your time and try to just visualize. Sometimes those are very difficult to visualize. Suppose you fold the net into a cube. What color is missing from each view? So this one we have red on top and yellow on the right. So red's on top, yellow's on the right. What would be in the front side then that adjoins the yellow and the red? Well, that looks like it would be the green side. How about in the second example? If purple is on top and this blue is on the left, what would be on the right? Well, if purple is on top and blue is on the left, then the red is going to be on that right face, okay, because that adjoins the blue and the purple would be the red. Then we have the orange in the front and the green on the right. So if orange is on front, green's on the right, what's going to be on the top? Well, that looks like it's going to be that blue side would be on the top. The net at the right folds into the cube shown. Which letters will be on the top and right side of the cube? Well, this one, we're going to have side B is going to become the front of our cube, and it says 4 of the 5 other letters will touch some side of face B. when it's folded into a cube. Cross out the letter of the side that will not touch side B or face B. Well, we can see that A touches, C touches, F will be the bottom, so it will touch, E will be the top, and it will touch. But the only one that doesn't touch is the side that's all the way opposite side B, which is side D. So we're going to cross out the one that doesn't touch, which is side D. Which side of the cube will that letter be on? Well, we already said that is on the back side, so we're going to circle that answer. And then it says use the net. Which face is to the right of face B? And how do you know? Well, to the right of face B is face C. And we know that because the right side of B and the left side of C are the same edge. Okay? And then moving down to question 19, using that net, which face is on the top of the cube and how do we know? Well, the top of the cube is going to be side E, and that is because it folds down. If you just imagine that, it folds down to become the top. Sometimes the reasoning on these are kind of difficult to figure out what they're looking for. Here we're going to write true or false. It says, what is a net for the figure at the right? Label the net with its dimensions. Question 20 says, 3 of the faces are rectangles. Well, if we think about each of these sides folding down, there'll be a rectangle here, and a rectangle on the bottom, so that is definitely true. 4 of the faces are triangles. Well, that one is false. There's only 2 triangles. The figure has 5 faces total, and that is true. So to write a description of the net, we could say that it has 3 rectangles and 2 triangles that form the figure that we see. Circle the net that represents the figure above. Well, remember we said that it has 3 rectangles and 2 triangles, so the only one that qualifies for that is this one right here, because this one does not have any rectangles and this one doesn't have enough rectangles and too many triangles. Is there another possible net for the figure? Well, actually there is for this one, and another net for the figure might look something like this. Okay, so it's very similar to the one drawn, but basically we take the left end and attach it over to the right end. What is an isometric drawing of this structure? Well, we have 3 cubes here, and it looks like the cube on top has one on the bottom perhaps, but we can't see that. The edges are all of the straight surfaces, those segments. And if we count all of those up, all of the vertical ones, and then all of the horizontal, and then all of the ones that go to the back, you'll find a total of 24 edges that we can see. And then the vertices are just the corners. All those vertices, if you count those up, you should get a total of 22 of those. I'm not sure that one's right. I think that's, yeah, that's a typo. That should be a 16. So let me just correct that here. That's a typo. Please don't put that in there. Your correct answer there, I'm glad I saw that, should be 16 vertices. Okay. Isometric drawing, then go ahead and try to draw the isometric view of this. I'll go ahead and draw a couple of these lines in for you so you can kind of see what that's going to look like. If you don't get it right away, just keep practicing. I've got lots of this isometric paper for you to use to draw with, so just kind of do what you can to see, see if you can visualize how this works out. And you should end up with a figure that looks basically like, let's see if I can get all my lines to come in here. They don't want to appear for me. There should be one coming out here, and then going down there. And one more. So there you go. That should be what your drawing looks like. And lastly, we have the last 4 questions, and I want you to bring the answers to those 4 to class, and please ask me in class what the answers to those are, and we'll double check them together. See you next time.